Hi, welcome to the pre-calculus lecture series. We have finished our chapter 5, the introduction of the trigonometry functions. So now for this video, we're going to take a look at chapter 5's practice test to see what type of the problems, in chapter 5, the can be, on the test, and so we can practice it. Okay, so now let's go to our practice test and start to work on it. Okay, and let me go there and find the practice test here. Okay, so now let's take a look here. For the first problems here, let me give a little bit more space here. All right, so now let's take a look here. So let's say the point PXY is on the unit circle and in the quadrant number 4, see here. If x is 11, square roots of the 11 over 6, I find y. So we know for the PXY, this is our point here, right? So this is a PXY, see here. And then we know that because this is the unit circle, so I know the x squared plus y squared equal to what? Equal to 1, right? So the x squared, so x is the square root of 11 over 6 to the square plus y squared equal to 1. So I have 1136 plus y squared equal to 1. So what is my y squares here? So y squared is equal to the square root. So it's 1 minus 1136. So this will be 25 over 36. Okay, so now I'm going to take the square roots, right? So when you take the square roots, you're going to have a positive or negative. So the y going to be plus or minus the square roots of the 25 over 36. Okay, so x can be, oh, that's pretty good, 5 and 6, or can be negative 5 and 6, right? So because this point is on the quadrant number 4, so what is my y value? See here, the y is what? Has to be negative, right? So that's what is my answers here. So my y values here is negative 5 over 6 here. Okay. Okay, now the next problem is here. So the next ones here is very similar problems here, right? So let me get this little bit more space so we can work on. Okay, so now let's take a look. Let's say the point P, so this is on the second quadrant, the y equal to the 4/5 here, all right? So let's try to find all these functions here. So the first thing is let's try to find the x squared plus y squared is equal to 1. So because they given y, I need to know what is the x. So it's x squared plus 4/5 the square equal to 1, right? So this would give you x squared plus 16 over 25 equal to 1. So then the x squared is equal to 1 minus 16 over 25. So what that would be? 9 over 25. Nice. And then the x here are going to be square roots. So it's a plus or minus square roots of the 25. So could it be the positive 3 over 5 or could it be the negative 3 over 5? Because I am in the second quadrant. So what is the x value? So x has to be negative. So this is my x values here. Okay, now after I get x, I get y. So I can start to find the sine, the trig function value. So what is the sine t? Sine is y, right? So it's a 4/5. Okay, then the b is a cosine t. Cosine is x, right? So it's negative 3/5. Okay, so c is a tangent. So the tangent t, tangent is what here is a sine over cosine. So it's a 4/5 over negative 3 over 5. So we know if you have the fraction over the fraction, so what do you do here? you kind of switch the bottom and the half, and you flip the bottoms, right? So what is the answers here? It's a negative 4 over what? Negative 4 over 3 here, right? And then this here is the second t. So what is the second t? Is 1 over what? Cosine t. So it's 1 over negative 3/5. So you flipped it. So it will be negative 5 over 3. Okay, so it's just use the basic definition about the trig function. Okay, so now the next thing here is said find the exact values, right? Okay, so find the exact value of those and the functions here. Okay, so we know the, like I said, we know the unit circle. We say the only things we cannot just need to remember, for the unit circles here is just the first quadrants, right? Even you have circles here, I just need to remember the first quadrant. So this one's here, right? So this one's here is what? Is 1/2. Oh no, this is square roots of the 3 and 1/2. Then this one's here, this is the square roots of the 2, 2, square roots of 2, 2. And this one's here is what? This one's here is 1/2, and then the square roots of the 3 over 2, right? So we say we only need to remember this, and this is 4 pi over 6. This is pi over 4. This is pi over 3, right? And then this is here. So this one will be 1, 0. This point here is 0, 1. So, okay. Okay, so the sine, so the sine is 7 pi over 6. Okay, so let's take a look at part A here. Sine 7 pi over 6. 7 pi over 6 is a little bit more than pi. So you go over here. So this is 7 pi over 6. So remember what we need to find? We need to find the reference angle. Reference angle is always the angle related to the x-axis, and it's always positive. So what is this reference angle? The whole thing here, 7 pi over 6. From here to here is a pi. So this reference angle is pi over 6, right? Okay, so pi over 6 is here. And the sine is y. So what is the answers here? Pi is 1/2, right? Okay. Now let's take a look at part B here. B is 13 pi over 4 here. 13 pi over 4. Okay, so it's like it's a pi. Okay, so here 13 pi over 4. So if you divide it by so it's a pi. So okay, so here, so this is the first one. From here to here is 2 pi. To another circle is 4 pi, and then 4 pi here is 5 pi, and here. Okay, so this is how. So this ones here you can say here. So you divide by it, and you will have what? And 13, so it's 3, right? Okay, so it's 3 pi plus pi over 4, right? So you make a whole circle 3 times. 1, 2, right? So it's, okay, so 1, 2, 3, right? 3 pi, right? Okay, so okay, so hold on, I did too many here. I kind of the continuous drawing here. All right, let's try again. So it's 3 pi over 4, right? Okay, so here. Okay, so this from here, right? So it's 1 pi, 2 pi, 3 pi over 4. Okay, so here, much better. Okay, so now where is my reference angle? This is my reference angles, right? So I got a 3 pi, so the reference angle is pi over 4. Okay, so pi over 4 is here. Let's take a look at pi over 4. Pi over 4, oh, cosine is square roots of the 2 over 2. But this is on the third quadrant. So cosine is x, so it's negative. All right. Okay, so now let's take a look at C here. C is 5 pi over 3. So here it's negative 5 pi over 3. Okay, so the negative 5 pi over 3, so it's like you go this way. So this will be the pi, somewhere go here. Okay, so this is a negative 5 pi over 3 because the whole thing will be 2 pi. So where is my reference angle? The reference angle is always to the x-axis. So this is my reference angles, right? So this is a 5 pi over 3. So I have a 1 pi over 3 left. So here this is a pi over 3. Okay, so pi over 3, you look for the tangents, right? So what is the tangents here? Tangent is sine over cosine. So 5 pi over 3, y is equal to the square root of the 3 over 2 over, and x is 1/2. So what is here? Square root of the 3. Because it's in the first quadrant, both x, y are positive. Good. Okay, so now the last one's here. So 3 pi over 2. Okay, so let's take a look at 3 pi over 2. So this is pi, 3 pi over 2. Oh, it's right on the, the right on the x-axis, y-axis. So, here, this is my reference angle is a pi over 2. Pi over 2 is here. So cosecant is what? Is 1 over sine, right? So 1 over sine, so it's 1 over 1. Okay, but in here, be careful. So because this is on the, in here, right? So it's on the, like this one, this y-axis. So what happened to the y? Is it negative or positive? It's negative. So you put a negatives here. So that's why your answers here is -1 here. All right. So this is how do I use the unit circle to find the value. Okay. So then the next thing here is said express t in terms of the sine t, and then the terminal point is in the quadrant number 2 here. So the purpose for this problem is to try to test us our idea about the trig identities, right? Okay, so let's start here. So I said tangent t. I know the tangent t, but the identity is what here? Is a sine t over cosine t, right? So I need to replace because they want the tangent t in terms of the sine. So what I need to replace out, I need to replace out the cosine with the sine. So where is the relation of the sine over cosine? They'll say, oh, Pythagorean. So I know the sine squared t plus the cosine squared t is equal to what? Equal to 1, correct? Okay, so then I can say the cosine squared t is equal to 1 minus the sine squared t. Okay, now I take the square roots both sides. So I said the cosine t could be the positive 1 minus the sine squared t. Also could be the negative 1 minus the sine squared t, right? And but let's say the t is in the second quadrant. That means I have a t is in here. If it's in the second quadrant, cosine is x. So x in the second quadrant is a positive or negative? It's a negative, right? So I need to take this one because it's in the second quadrant, right? Okay, so now I can replace back. So I will say the substitute back here. So what is my final answer? So will be the negative sine t, and this is 1 minus sine square t. Okay, that's how do I show it. Okay. Okay, so now let's take a look at the problem number 5. It's very similar like the one we did before, and let's see we know how to do it. So let's say the cosine t is equal to the negative 8 over 17 here. All right. And the terminal point is in where? In the quadrant number 3 here. I want to find the tangent times cotangent plus cosecant here. All right. So like for this one here, we always need to do what? I need to find the x and the y's, right? So let's do the same things. X squared plus y squared equal to 1. Cosine is x, so it's negative a over 17 squared plus y squared equal to 1. All right. So this will be 64. 8 times 8 is 64, 289 plus y squared equal to 1. So what is y squared? Y squared is 1 minus 64, 289. Correct? All right. So now I can find these ones here. This is 225 over 289. Okay, now you take the square roots. So the y could be the plus or minus the square roots of the 225 and the 289. So what is the square root? So that could be the positive 225, the square root is 15, right? So 289, 17, or it can be 15 over 17. So let's take a look. Let's say, hey, it's in the quadrant number 3 here. That means my point is in here. If in here, my y is positive or negative, so this is x, this is y. So what happened to my y? Y has to be negative. So this will be my answers for y's, right? Okay, so now they ask us tangent t times cotangent t plus cosecant t. Okay, so now, of course, you can change that, but in here, take a look at tangent t times cotangent t plus cosecant t. I know the tangent and the cotangent. What is that? What type of identity I have? They are the reciprocal of each other, correct? So tangent t times cotangent t will give you what? Will give you 1, all right? And then the cosecant t is what? It's 1 over sine t. So, okay, so now let's try to see what is our final answers here. So this is 1. Sine t is y's, right? So it's 1 plus 1 over negative 15 over what? 17 here. Now you flip. So this will be 17, 15. Correct? So now what is the answers here? It's a negative 2 over the 15th here. All right. Okay. Okay, now let's take a look at the problem number 6 here. This is the one we talked before. Yes, about the functions here. All right, so now, okay, so let's see, what they want us to find. They want to find the amplitude, period, phase, and the horizontal shift, right? Okay, so now, okay, let me write down the formula so we can see. So remember that we have A, sine or cosine, doesn't matter, K, like X minus B, right? So we say, what is this A here? This is what is the amplitude, right? The absolute value of its amplitude. And what is this here? This one is affecting what? Affecting the period, right? So I can say the period is what? Is 2 pi over k. And what is this? This is the shift, right? So this is the shift, okay? Okay, now let's take a look here, right? So so now they want us also graph it. Okay, so here, first things here, let's take a look. This one's here is 5. We know the amplitude is what? Amplitude is the absolute value of this, right? So here, the amplitude is 5. And then the next things here, this is 4. So what's that mean? That means this one's here, the period going to be what? 2 pi over 4. So what is the period here? It's pi over 2. See here. Do I have any horizontal shift? I say no shift, right? No horizontal shift. Okay, now let's take a look at this one. See here. So this one, okay, so first things, this thing's in the front of it. So what is this? That's amplitude. So I know the amplitude is equal to 2. Okay, so for the inside here, I have to have the k come out is minus b. So I need to factor the 1/2 out. So this is 2 sine. Remember, k has to be outside. So I have to take the 1/2 out. So if I take the 1/2 out, so here is the x. So what is here? Because you take a 1/2 out, how many left? So it's pi over 3, right? Okay, so now I change it to my standard form. So now I can determine my period here, right? So what is the period here? So the period will be 2 pi over 1/2. So you flip it, going to be a 4 pi. And now the last things here, this is a shift, right? So it's because it's minus. So what is I have here? I have a horizontal shift to the right. How many units? Pi over 3, okay? Okay, now let's try to graph both the functions. And then from the next page is here, let's get a more space. Right, do I have enough space? Okay, good, enough space. Okay, so I need to see what is the function. Okay, so negative, okay. All right, so now let's take a look. All right, let's kind of, okay, so here. So this is a cosine, right? Okay, so let's do this. Okay, so remember, there's no shift here. So the key things we did, you know, is how do I know the 4 subintervals, right? So you need to use your period, right? So you need to use this period, then do what? Divide by 4, correct? All right, so you need to divide pi over 2 by 4. So what is this ones here? It's a pi over 8. So what is a pi over 8? That is the length of a subinterval, right? Because I have a 4 subintervals here. Okay, now let's try to do this ones here, right? So, okay, so you can base, okay, so the amplitude is 5. So you say here's a 5, here's a negative 5. Okay, so now let's take a look here, right? So each subinterval is pi over 8. So my first, because there's no shift, I start here. So the first subinterval is pi over 8. Then you need to add another pi over 8. So what is here is pi over 4. Then you need to add another pi over 8. So what is here is 3 pi over 8. Then add another one, pi over 8. What is here is pi over 2. You can continue, right? Okay, so original, all right, so, okay, so maybe this one's here is, I need to have a little bit long. Okay, let me see here. Okay, so, all right. Okay, so here is negative, it's too long. Okay, maybe too long here. This is negative 5. All right. Okay, so you know, we know the parent function of cosines go like this, right? So I already have this 4, so my dot, 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 like this one. Okay, but I have a transformation. What is this transformation? Negative, right? I have a negative. So what does that mean? That means it's reflecting over the x-axis. So what is my final graph going to look like? Hey, my final graph going to look like this one, going to flip to here. So going like this. Okay, so this will be the negative 5 cosine 4x. As you can see, it complete a whole cycle, and it's pi over 2. So that's why, that's why the period is the pi over 2. Okay, now let's take a look at the other ones here. Okay, so remember the key things here. I need to divide the period, right? So I said divide 4 pi by how many? By 4. So 4 pi divided by 4 is what? This is pi. So what is this pi's here? This is the length of the subinterval. All right. Okay, so this is the length of the subintervals here. Okay, so now also is a shift pi over 3s, right? Okay, so now let's try to graph it. So this is a sine, right? So sine. Okay, so first let's mark the amplitude is 2. So this is a negative 2. Okay, so the first thing here is shift pi over 3. So I will say here, this is pi over 3. So that means I'm going to start here, right? So this is a pi over 3. All right. Okay, so I'm going to mark here. This is a pi over 3. I'm going to start. And each subinterval is pi. So what I need to do is here, I need to add a pi here. So what is a pi plus pi over 3? This is a 4 pi over 3, right? So now I have a da, 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 da. Then I add another pi. So what is 4 pi over 3? When I add another pi's here, it's 7 pi over 3, right? Okay, so this is my second interval. Then I add another pi, 7 pi over 3 plus another pi. So what is here is 10 pi over 3. So this is my other one. And then I add another pi. I need to have 4 subintervals, right? So it will be 13 pi over 3. See here. Okay, so remember the sine parent function is go like this, right? So now I can graph here because I'm starting here, right? So that's why I can have this. So it's go like this. All right. Okay, so now as you can see, I complete one cycle, and here in this area, right? So what is the 13 pi over 3 to the pi over 3? It's 4 pi. That's what is the period. It's 4 pi here. Okay, it's a pretty, so the what is the key things when you try to plot here? You make sure you know the key things you try to plot. Don't forget, you need to divide it, right? So because the sine and cosine is like 4 subintervals, so you divide by 4. If it wants you to graph tangent and cotangent, then you divide it by 2, right? Okay. Now, okay, find the, okay, so here, this is another, yes, this is the inverse functions here. Okay, so for the inverse functions, okay, so remember the key things for the inverse functions during the lecture, we keep emphasizing, all right? So for the, we have restricted domains, right? So for the tangent x, the domain restricted is from negative pi over 2 to the pi over 2, right? And cosine, the restricted domain is from where to here? 0 to pi. And the sine, x, the restricted domain from what? Negative pi over 2 to the pi over 2 here. Okay, so now let's take a look at part A is here. Tangent, arctangent 1. So that means in this interval, negative pi over 2 to pi over 2, which value will give the tangent 1? Is what? Is pi over 4 from the unit circles, right? Okay. Now part B is here. So I have a cosine, negative square root of the 3 over 2 here. So from the 0 to pi, which value will give me the negative square root of the 3 over 2? Look here, this is the cosine, right? We restricted from the here, this is the pi here, right? So the negative square root of the 3 over 2 will be where? Will be somewhere here, right? So this is the negative square root of the 3 over 2 here. So what is the angle? What is the angles here? If you remember, right? So this is will be 5 pi over what? 6. Okay, the reason why it's 5 pi over 6 because you know the negative 3 over 2 is here, so then the next one here will be negative 1, and so it's pi over 6 is the reference angle if you look that way. Okay, so then this is a tangent, arctangent, tangent 3 pi. Okay, if we said you can do the cancellations, like because one is inverse, one is not. If the angles here, if the angle is, oops, this is 3 pi. So we say it is okay if the angles here is within the restricted regions. Then we can just cancel that out. But for this one, I cannot. So I need to do each one. So I will figure out. So this is the arctangent. So what is the tangent 3 pi? Okay, so the tangent, if you do the general graph here, okay, so tangent 3 pi. Okay, so this is a pi, 2 pi, and 3 pi will be zeros, right? So it will be 0. So what is the arctangent? 0, it will be 0, right? So it's not, you can just cancel out equal to 3 pi. It will be equal to 0 here. Okay, now let's take a look at the D's here. This is a cosine, arctangent, negative square root of the 3. Okay, because the tangent, the restricted region is negative pi over 2. So here you have to come out with a negative value. So negative square root of the 3. So what is that? It's negative pi over 3 for the tangent from the unit circle. Then this one here is equal to the cosine pi over 3. Why? Because cosine is an even function. So negative is equal to the positive, or the reference angle is pi over 3. So what is the cosine? Pi over 3 is what? Is 1/2, right? So it's back and forth about, find the unit circles here. Okay, so then in here, let's take a look at determine the functions here. This is pretty interesting, right? So they give us the functions, and the first things here, you say, hey, this shape is kind of like the sines, right? Okay, so first things you recognize, what do you recognize here is this number, right? So what's that mean? That means it's amplitude, right? So the A is equal to 2. Okay, so now the next things here, that's like we talked before, typical is the hardest one, is the period. So you see from here to here, right? They completed the whole cycles there. So negative pi over 3 to the 2 pi over 3. Okay, so the 2 pi over 3 to the negative pi over 3. So how many pi's here? So it's pi's, right? Because that's the distance from here, negative pi over 3 to the 2 pi over 3, right? So it's a pi. So that means this is the period of this function. So I know the period is 2 pi over k is equal to pi. So what is my K number? K is 2. All right. And then the next thing here is this number is the shift. Okay, so obviously this one's here because my sign is starting here like this, right? Parent function. Now you shift, you starting here. So what is shift here? I shift to where? I shift to the left, right? Pi over 3. So that means in here, I can write these functions here. I said, what is my final function will look like? This will be 2 sine 2 x. Okay, be careful. I shift to the left. So what I need to do? I need to plus pi over 3, right? Because it's negative pi over 3. All right. All right. So let's take a look at number 9 here. So the number 9 tells us that, okay, so the number 9 tells us that a sine curve and this one and this one, they have, okay, so they have the same period. Find the face of each curve. Okay, so now because they have the same period, okay, so let's take a look here. So y1 is equal to 30 sine. Remember the period. You have to have a constant. So remember this is a sine k x minus b, right? So the period you have to what? In front of it, all right? Okay, so now this I need to take the 6 out. If I take the 6 out, what is here? This is t. Pi over 2, I take a 6 out. What is I have here? I have a pi over how many? 12. That's right. Okay, so the y2 here is 30, the sine, the same way, I need to take the 6 out. So this is a t. So if pi over 3, I take a 6 out. What do I have here? I have pi over what? 18. Okay, so now I know, look here, they have 6, they have 6, so both of them have the same period. Okay, so what is the shift here? So this is the shift, this is a what? Pi over 12 to the what? To the right, right? This one's here also, this is a shift to the right also. What is here? Is pi over 18. Okay, so that's what we call this. The shift and the phase is the same things. Okay, so here we use the phase, basically is the shift, right? Okay, so part B, they ask us what is the phase differences between the y1 and the y2. So I know the differences here. Because one is pi over 12, one is pi over 18, so it just be pi over 12 minus pi over 18. So the shift differences is pi over 36. Okay. All right. So now let's take a look at the last problem here. This is the word problem. It's very interesting word problems here, right? Okay, so now for this ones here, let's take a look. It says, okay, so it says a mass is suspended from a spring oscillating in a simple harmonic motion. The mass completed 2 cycles. Okay, so this is the key things we need to highlight. So 2 cycles per second. And the distance, okay, and the distance between the highest point and the lowest point of oscillation is 10 centimeter. It's a 10 centimeter. Find the equation of the form. So I want to find a sine form that give the distance of the mass and the position functions. Okay, so here, let's take a look here. You know, I know the sine functions here, right? Okay, so I know this is my amplitude, right? So this is the height here, we call this amplitude. So if you look the sine function from the highest point to the lowest point, what happens here? Amplitude just a half of it, right? So in here, they say the distance between the highest point and the lowest point is 10 centimeter. So what I conclude here? So I know the amplitude will be what? 10 divided by 2. So it's what? It's 5. All right. Okay. Okay. So now the hardest part is this cycle things, right? So I said 2 cycles per second here. Okay, so that means every second I completed 2 cycles here. So what's that mean? The 2 cycles per second. That means the period, right? So the period is like how, when we complete the whole cycles, right? So period is what? Really is 1/2 here. But now I need to change to the WTs, right? Okay, so I know that these numbers here, remember here, and here, let's see here, where's my, okay, here's a highlighter. So this W's here, right? So I know the period for the sine. How do I define the period for the sine? It's 2 pi, I divide by that constant W. And this is how do I define the period. This is a period. So that's why this is equal to what? Equal to 1/2. Okay, so what is my W equal to? You do a cross product. W equal to 4 pi here. All right, so now I can write my function. So let's try to here. So y equal to the 5 sine 4 pi t. That will be my periodical functions here. Okay, that's it. And I hope we did this practice test can help you to understand this chapter better. So when you come to the exam, you will get a very good grade about your exams here. All right. So hope this help and nice talk to you and looking forward to start a new chapter next time. Okay, bye. Talk to you later. Okay, bye-bye.